Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. Apache Shindig is a powerful open-source framework developed by the Apache Software Foundation. It enables developers to integrate Gadget's small, reusable web applications into larger platforms like dashboards, portals, and social networks. Originally inspired by Google Gadgets and iGoogle, Shindig implements the OpenSocial specification and supports secure cross-domain communication using OAuth. In this tutorial, we'll explore how Shindig works under the hood and how you can leverage it in real-world applications. At the heart of Shindig are Gadget's lightweight web applications typically defined in XML files. These gadgets can include HTML, CSS, and JavaScript, and are rendered inside iframes for security. They communicate with backend services through REST or RPC calls, and can display dynamic data like social feeds, calendars, or analytics. Gadgets make it easy to build modular UIs without reinventing the wheel. Shindig is composed of several core components. The Gadget Server fetches and renders gadgets securely. The container framework provides the runtime environment for embedding gadgets. Shindig also implements the OpenSocial API, enabling social features like friends lists and activity streams. Finally, it includes a robust OAuth proxy and security layer to handle cross-domain communication safely. Let's take a closer look at Shindig's architecture. The system follows a gadget rendering pipeline that includes fetching Gadget XML, parsing metadata, rewriting content for security, and rendering inside a container. Security is handled through a proxy layer that sanitizes and signs requests, and OAuth tokens are used to authenticate API calls. This layered approach ensures both performance and security. Gadgets in Shindig are defined using XML. The module prefs section contains metadata like title, author, and thumbnail. The content section defines what gets rendered, including HTML and embedded scripts. Gadgets can also define user preferences and request specific features like OAuth or dynamic height. Understanding this structure is key to building custom gadgets. Security is a critical part of Shindig. The framework rewrites gadget content to sanitize HTML, CSS, and JavaScript, preventing cross-site scripting attacks. It also signs URLs used for proxying external resources, ensuring that only trusted domains are accessed. This process is handled transparently, allowing developers to focus on functionality rather than security plumbing. Shindig supports OAuth to securely access third-party APIs. It uses a proxy-based model where OAuth tokens are managed by the server and signed requests are made on behalf of the user. This approach allows gadgets to interact with external services without exposing sensitive credentials, while still enabling rich, personalized experiences. Shindig implements the OpenSocial API, enabling gadgets to access social data like friends, activities, and user profiles. It supports both REST-full and RPC-style endpoints, making it easy to integrate with existing social platforms. This allows developers to build socially aware gadgets that can enhance user engagement and personalization. Containers are responsible for embedding and managing gadgets. Shindig provides APIs for integrating gadgets into web pages, handling lifecycle events like resizing, preferences changes, and user interactions. Developers can also build custom containers to tailor the experience for specific platforms or use cases. To ensure optimal performance, Shindig supports several optimization techniques. These include caching gadget metadata and content, preloading frequently used gadgets, and bundling resources like CSS and JavaScript. These strategies help reduce latency and improve user experience in large-scale deployments. While Shindig is inspired by Google Gadgets and iGoogle, it offers more flexibility and extensibility. Unlike legacy systems, Shindig supports modern web standards and integrates with OAuth and OpenSocial. However, newer frameworks like React-based widgets or micro frontends may offer better performance for modern applications. Setting up Shindig is straightforward. You can download the binary distribution, configure it to work with your container, and deploy it on a servlet container like Tomcat or Jetty. Once deployed, you can test it using sample gadgets provided in the package to ensure everything is working correctly. Creating your first gadget is simple. Start by writing an XML file that includes module paths for metadata and content for rendering. You can then deploy it in your Shindig container and test it in a browser. This process allows you to quickly iterate and build rich, interactive components. Gadgets can support user preferences defined in the XML file and accessed via JavaScript APIs. Users can change settings like theme, language, or data sources, and these preferences are persisted across sessions. This allows for highly personalized gadget experiences. Shindig supports dynamic resizing of gadgets based on their content. This is done using JavaScript APIs that notify the container when the gadget's height changes. This feature improves layout flexibility and user experience, especially for gadgets with variable content sizes. OAuth integration in gadgets is handled through Shindig's Proxy, which manages token requests and refreshes. Gadgets can securely access external APIs without exposing credentials, ensuring that sensitive data remains protected while enabling rich functionality. Shindig uses a proxy to rewrite and sanitize gadget content and Caja to sandbox JavaScript execution. This combination ensures that gadgets can safely access cross-domain resources without compromising security. These features are essential for multi-tenant environments. Shindig supports internationalization by allowing gadgets to define message bundles for different locales. This enables content to be rendered in the user's preferred language, improving accessibility and global reach. Developers can easily add translations using standard XML structures. Debugging gadgets can be tricky, but Shindig provides tools for both client-side and server-side logging. You can use JavaScript console logs for client-side debugging and inspect server logs for proxy or OAuth issues. Proper error handling ensures a smooth user experience. A common use case for Shindig is building dashboard widgets. These can include custom analytics panels, social feeds, and third-party service integrations. By using gadgets, organizations can create modular, personalized dashboards that improve productivity and engagement. In enterprise environments, Shindig can be used to build secure, role-based portals. Gadgets can be integrated with internal tools like CRM or ERP systems, and access can be controlled based on user roles. Custom branding ensures that gadgets align with corporate identity. Security should always be a top priority when working with Shindig. Use Caja to sandbox JavaScript, validate all external inputs, and regularly audit OAuth tokens. These practices help protect against vulnerabilities and ensure that your gadgets remain secure. Shindig is highly extensible. You can write plugins to add custom container APIs, integrate with new OAuth providers, or introduce new gadget features. This flexibility makes it suitable for a wide range of enterprise and web applications. Monitoring performance is crucial for maintaining a good user experience. Track gadget load times, monitor proxy latency, and use caching effectively to reduce overhead. Tools like Apache JMeter can help you benchmark and optimize your Shindig setup. Common issues with Shindig include gadgets not rendering, OAuth token errors, and cross-domain access problems. These can often be resolved by checking logs, validating XML syntax, and ensuring proper proxy configurations. A solid understanding of the architecture helps in troubleshooting efficiently. While Shindig excels in legacy and enterprise environments, modern micro frontends offer better scalability and performance for large-scale web applications. Choosing between them depends on your specific use case, infrastructure, and performance requirements. Let's look at a real-world case study, a social intranet portal built using Shindig. The portal includes gadgets for team feeds, calendars, and task management. These are integrated securely with internal tools, providing a unified and personalized experience for employees. While Shindig's community is smaller than in its heyday, there are still valuable resources available. Check Apache mailing lists, GitHub repositories, and legacy documentation for guidance. Engaging with the community can help solve complex integration challenges. Shindig is currently in maintenance mode, with limited active development. Many organizations are migrating to modern frameworks like React-based micro frontends. However, Shindig remains a viable option for legacy systems and enterprise environments requiring robust gadget support. Here's a detailed diagram of Shindig's workflow. It begins with a gadget request from the container, followed by XML parsing, content rewriting, OAuth token handling, and final rendering. Each step is designed for security, performance, and extensibility. This chart compares Shindig's performance against other gadget frameworks. While it may not be the fastest, its strength lies in security and enterprise-grade features. Understanding these trade-offs helps in choosing the right solution for your needs. Let's walk through the OAuth flow in Shindig. The gadget requests a token via the proxy, which signs the API call and handles token refresh. This ensures secure access to external services while keeping credentials safe. This diagram illustrates Shindig's layered security architecture. It includes content rewriting, Caja sandboxing, and sign proxying to ensure that gadgets remain secure while interacting with external systems. Here's a sample XML structure for a gadget. It includes module prefs for metadata, content for rendering, and preferences for user settings. This is the foundation of every gadget you build with Shindig. Integrating gadgets into containers involves embedding them in web pages and handling lifecycle events like resizing and preference changes. You can also extend containers with custom APIs to support advanced features and integrations. When deploying Shindig, use caching and CDNs to improve performance, secure OAuth tokens, and monitor system health regularly. These practices ensure that your gadget-based applications remain fast, secure, and scalable. Apache Shindig is a powerful framework for building modular, secure gadgets. While it may not be the newest tool on the block, its enterprise-grade features and robust architecture make it ideal for specific use cases. If you found this tutorial helpful, don't forget to like, subscribe, and share your questions in the comments below. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.